Thank you. How do I advance? Oh, this one. Okay, good. Morning, everyone. I'm going to talk a little bit about these great questions, passions, challenges, and wishes. As a way of introducing myself, I decided I'd take a look at my past publications and then do a word chart for you. So I don't know if I can point here, so I can't really point, so trust me. My work is on perceptual data visualization and electronic imaging. I'm very interested in methods and systems. A lot of these methods are rule-based, interactive, and adaptive. I'm really worried about semantics and features, segmentation, and if you look closely in the small print, I've worked with a lot of people in different technical domains and industries, and I'm interested in lots of problems in visualization and in data analysis. So my background is experimental psychology. My PhD was in spatial temporal modeling of visual systems. Right. So what I'm passionate about, I'm very interested in what I call the representation problem. So you start off with some data. I guess I can't point, but it's okay. You start off with some data. You create a visual representation. But the important part is, you have a lot of tools that allow you to map the data onto different visual dimensions. But the important piece is, how are these representation parameters going to be perceived and used by the human observer? So for example, let's say you start off with some data. People are very concerned with, let's say we create some data, we want to map it onto some visual dimensions. A common one for the rainbow color map. For every value of the data, you map it onto a value of the color map, and you create a representation. And then people say, okay, you're done. But the question I'm worried about is, what about for every step in the data, in the representation variable, what is the perceived value? So you want equal steps in the data correspond to equal perceptual steps, for example, if you're representing magnitude, and but you want equal steps in the color map to correspond to equal perceptual. That ends up making a difference when you're trying to do data visualization. So here's a set of data. This is just elevation data for somewhere in the United States mapped onto a rainbow color map. One of the things that you do notice here is that the ranges there are different data values, but perceptually it looks identical. So one solution is to try to create what I would call perceptual color maps. In this case, the data values are mapped onto a color scale where the lowest value is dark and it increases monotonically to the highest values being light. And also a color was introduced to say, okay, here's sea level. We know that at sea level we can use color mapped on top of that to give you some semantic representation. So, oh, sorry folks on the phone. Okay, so here's an example of using these principles with a recent consulting job I did with CERN. This is the Higgs boson data. In this case, they knew exactly what they were looking for. The Higgs boson had a signature that was 127 giga-electron volts. And here's the representation that I started with. They mapped a rainbow color map onto this. Okay, so the first thing we did is we said, well, what if we don't use a rainbow color map? What if we use something that has a monotonically increasing luminance value? And you can see there's a little bit more in the dark region. You'll see there's a region where that's more important. But one of the things that you notice is a lot of the data values are sort of bunched up. So why not do a log transform on the data? All of a sudden you start to see that there may be something there of importance. And then you say, well, but even then, a lot of those, that dark spot takes up a large part of the color map. Maybe what you can do is add another dimension or redundantly map the data values, the giga-electron volts, onto a distance. And so you can come up with this map, which gives you a very clear view for communicating. This is, you're proud. This, look, we found the Higgs boson. So this helped a lot. This is an issue of communication, but it's not just a small difference. What you come up with at the beginning and what you end up with at the end, if you use some principles of perception and cognition, you can end up having more importance. Okay, I'm interested in mapping. How do you map data onto different representations? these are 4 representations of the same data. They look very different, and when I have more time, I can go into this. I'm very interested in finding semantic features. How do you use human pattern recognition to find features? A lot of us use data. We have an algorithm. The algorithm identifies some features. You may have some interaction. Maybe you create a visual representation. You have a human being at the end who's detecting it. But I think that the model that we have the human at the end is incomplete. So the human may certainly see a feature in that final presentation, but maybe the human should interact with the data. Maybe the human should interact with the algorithms, with the representation, the algorithm, and the data. So current challenges. In consulting, I have a lot of challenges that have to do with entrenched attitudes, like visualization is a pretty picture after the real work is done. Why do we need perception research? Well, we have, everybody can see. And I think that there's a lot of, work that's done. We don't have a data science curriculum. So just want to say my wish list includes, one sentence, visualizing models, visual analysis and problem solving, risk, uncertainty, and interaction effects, haptic interfaces. And I think that one of the things we really want to work toward is a taxonomy of analysis tasks, which can be mapped onto different representations that enable different kinds of human characteristics, so that we can apply this science of visualization not just in one silo, but across all the silos. Thank you very much.